One of the most difficult portions of Chapter 9, and actually Chapter 10 and 11 will have the same issues, which is when do I do what, right? So we have a whole bunch of different formulas, and the trick is knowing which one to use when. All right, so this flow chart, we're going to go over confidence intervals. So we're going to be constructing a confidence interval. So if the instructions say construct a confidence interval, if you see those words in there somewhere, then these are going to be your two options, at least at this point in Chapter 9. Okay, so we've had two main intervals, and you can see them if you look at our exam notes packet that we've seen. Let me go grab that. Here we go. So in our exam notes packet, Appendix A, there's the Chapter 9 confidence intervals, and there's this one, which is for a single proportion, P. There's two formulas, but they're essentially the same formula, so no difference. And then there's this one for a mean. So those are our two options, proportions and means. All right, so let's look at that in the flowchart. Okay, so for our intervals, we can have one that's for a proportion. So that would be my parameters P, and this would be my parameters mu. So I'll do this in different colors. So this one would be P hat plus or minus Z alpha over 2 times the big square root P hat times Q hat over N. I'm writing the formula that I use the most often, which is the full formula. Okay, so how are you going to know a problem is asking about this, right? How are you going to tell? Well, in the problem, it'll have words like proportion, right? Proportion's a good sign. It'll have percents. Now be careful. The confidence percent does not count. These ones will have confidence levels as well, and confidence levels are usually written as a percent, like 95 or 99%, something like that. But you're going to look for another percent besides the confidence, right? So percent besides confidence, right? Besides the C level, your confidence level. And if they talk about a survey or a poll, oops, I've run out of room, right? Survey or poll. Let me kind of nudge that over, right? So if they talk about a survey or a poll, sorry, that's off screen. There we go. I got it now. A survey or a poll, that will be for proportions. Simple as that, right? So look in the problem, read the words they're talking about, read the situation. If they're talking about a survey, it's going to be proportions. All right, now in technology, there's two options. So most of us are using StatCrunch. And when you're using StatCrunch, and those instructions are on the same packet that had the exam notes packet. So if I pull this up, it says it right here. Stat, proportion stat, one sample with summary. If you're using a calculator, it's one prop z int. So write whichever one of those is appropriate for you for your situation. So if you're using the calculator, write one prop z int for yourself. If you're using StatCrunch, write this set of instructions for yourself. Either one's fine. So I'm using StatCrunch. So in StatCrunch, it'll be stat, proportion stat, and then it'll be, oops, I'm going to kind of separate those. And then it'll be one sample with summary. So that's a lot, but it's actually usually easier than the calculator. If you've got the calculator, write one prop z int. So that'll work fine. Here, I'll put the calculator right here. So if you're in the calculator, if you're a TI-84, don't write this if you're not using the TI-84. There's no point. So it's one prop z int. Right. So write whichever one of those is appropriate for your situation. Now, this was in section 9.1 that we covered this, right? And you can go look at the page, but so I'm not going to write this. It's whichever page is on your exam notes packet for your semester. The semester I'm currently writing this in, it will be page 273, but this could change. So it's right here. It's the 9.11, right? Section 9.1. So for me, it's page 273, but write whatever page of your notes packet you have it on, okay? So it'll be the top box, though, I can tell you that. So for me, this semester, it's 273 top box. So it's the first box on that page. The critical values, and you can see it when you look, the critical values are the z alpha over 2s, right? Plus or minus z alpha over 2. Okay, so plus or minus z alpha over 2. And the requirements for normal are the thing that changes from proportions to means. So in proportions, to be normal, I need n times p hat times q hat to be greater than or equal to 10. Sorry, I just went and grabbed the yellow packet because it's right here, but it's the yellow packet that I'm looking at, but mine's not yellow, it's white paper, but that's what I'm grabbing. All right, now I didn't put it in here, but it occurred to me that I should mention it one more time. So if you remember, the part that's after the plus or minus, let me do this in like blue, a different colored blue. That part right there is the error. So the margin of error is actually the z alpha over 2 times the big square root p hat times q hat over n. That's the official formula for the margin of error, right? It's whatever comes after the plus or minus. So from there to there, that's your margin of error. Now, it doesn't hurt to remind yourself of that. All right, now what about the other confidence interval? So this one's going to be for proportions, this top one. So if it's talking about proportions, that's the one. So what's the other formula? Well, the other formula is x bar plus or minus t alpha over 2 times s over the square root of n. That one will be looking for mean or average, right? A lot of times they'll say average. There'll be a standard deviation somewhere in the problem, possibly. Or if they give you a table of data. So if you see a problem with a big data set, that has to be a means one. That cannot be a proportions one. Proportions ones don't work like that, at least not in our course. There are ways to do it with data, but we're not doing it. So for us, table of data will automatically mean it's a mean, which means the parameter we're looking at is mu. And this was section 9.2. It's, again, change this page based on your semester. But for me this semester, it's 273 in my yellow packet, in my appendix A. And it's the second box. It's the bottom box on that page. The critical values you can see are plus or minus t alpha over 2. I mean, it's right there in the formula, t alpha over 2. And I know I've skipped the technology. I'm going to go back. I just didn't want to try to do all this at once. All right, so then the requirements for normal, right there, n bigger than 30, or a graph, right? Or it could be just given to you. I didn't mention that in here, but I could just say it. If I just say it, then it's fine. So it could be given, or it could be a graph, right? Those normal probability plots that I love so much, or n greater than or equal to 30. The greater than or equal to 30 one we use a lot, but we also use this graph one a lot. I do occasionally even just give it to you in the problem. So that works too. Okay, so then what about technology? Okay, well, write it down based on your particular issue. So I'll grab the electronic version this time. So down here for StatCrunch, it's a choice. So it's stat, t-stat, and one sample for sure. If you have a data table, then you're going to use with data. If you just have a big old paragraph where they kind of explain everything, then it's going to be with summary. So it's one of those two if you're in StatCrunch. So it's either with data or with summary, but it's stat, t-stat, and one sample for sure. If it's a TI-84, then it's t-interval. Right? So write whichever one's appropriate for you. So if you're doing StatCrunch, which I am, so I'm going to write that. StatCrunch is right here. I'm just going to say stat, t-stat, and then it's one sample, and you have to choose with data or with summary. It could be either one. It just depends on your problem. If your problem has the data set, then use with data. And of course, you have to have that data put into StatCrunch, which you might not. So it has to be there. And then if it doesn't, then use with summary. Okay. Now, if you're using the TI-84, I'll just kind of throw that TI-84 in there. Again, don't write this if you're not using a TI-84. If you are using a TI-84, it's t-interval. Okay. All right, now what about the margin of error this time? Well, just like before, it's whatever's behind that plus or minus. So I'm going to have to do this in like orange here, right? So there's the error right there. right? So the margin of error, I know I didn't have that in here, but I really should have. So let me just kind of throw this in. The margin of error is the whole back half. So it's t alpha over 2 times s over the square root of n. In other words, it's t times the standard error, because s over the square root of n is the standard error of x bar. That's the margin of error. All right. Now, there have been a few more highlights that we've hit in Chapter 9 that we don't want to forget. First off, alpha and our confidence level are complements of each other, remember? So let me just grab a marker here. So alpha and the C level are complements. We learned that in section 9.1, and it held true for the rest of the chapter. It's always going to hold true. Alpha and your confidence level are complements of each other. Then there's the interpretation, which we tend to stick with the informal interpretation, which is we are blank % confident that the true population parameter is between the lower and upper confidence level limits. And you'll put your context. So a couple things. So with this one, let's say right here with this, we are blank %. That'll be your C level. So you'll put your C level in there, whatever that is. So 95%, 90%, whatever that might be, you'll put it in there. This true population parameter business, that's either P or mu, right? Proportions or means, but you're going to have to use context, right? You're going to have to talk about it, right? What's the situation? What is it we're talking about? We're talking about averages. We're talking about proportions. What are we saying? So the true population mean or the true population proportion. So this is proportions. This is means. Everything in these chapters, 8, 9, 10, 11, is all means, proportions, means, proportions. So you have to figure out which one you're working with and then talk about it. All right, don't also forget that all confidence intervals that we are learning are based on a basic formula, which is your point estimate plus or minus your margin of error. That is how they work. Oh, margin of error. I lost room for my R in there. 1 second. Margin. There we go. There we go. That is the basic formula that all of these follow. They're going point estimate plus or minus margin of error. And you see it, that's what I was saying. X bar is your point estimate plus or minus margin of error is the back half, right? There's your point estimate. There's your error, right? Same thing with this one. There's your point estimate. There's your error. It's the back half. And actually, I'm going to skip this for just a second and just kind of reiterate. If this is true, then that leads us to, I should put it in there, but I don't have room for it. So let me just tie this in. So that leads to some formulas that we've learned, right? Because confidence intervals follow this formula, that means that the point estimate, right? Because think about what a confidence interval is. A confidence interval is lower, comma, upper, right? You have a lower value and an upper value, right? That's a confidence interval. So that means that your point estimate has to be the average of the lower and the upper. So you take the lower plus the upper and divide by 2, and you will have your point estimate. And similarly, if you have the interval, the margin of error, even though we have the formulas up above that are like the fancy formulas, if you have the margin of error, I don't know why I put an S on that, that would be the upper minus the lower divided by 2. That comes from the fact that a confidence interval is lower here, upper here, point estimate in the middle, right? That's the error here. I should have gone lower. Sorry. That's the error, and that's the error, right? So if that's the case, there you go, right? If that picture is true, then that's how you can figure this out. You got your lower here, your upper here, point estimate in the center right here. Error is that distance. So you can use these formulas if you have the interval. Can use these formulas if the interval is known or given. right? If you find it, or if you know the interval or whatever. Okay, so that's a lot to take in. So those pieces all come together. I should have put those together. Sorry about that. So those pieces go together. Last but not least, there's something we learned in the last section of chapter 9 before this one, which is the sample size and margin of error. There's relationships there, right? So we learned that sample size, which is n, increases, then error, the margin of error, would decrease, or vice versa. Right? There's a relationship there. So I'll just kind of separate this out. There you go. You can see it, right? So if your sample size increases, your error decreases. Similarly, if your confidence level increases, then your error increases. Right? That's just the way that goes. And then standard deviation. If your standard deviation, which is S, increases, then error increases. Okay? So this one is the weird one. This is the one that goes backwards. Oops, sorry. I hit the page. So this is the strangest one of the three, right? Because this one has an inverse relationship. If sample size goes up, error goes down, and vice versa, right? They're on a teeter-totter together. Whereas these other two, they're actually working together. If confidence level goes up, error goes up. If S goes up, error goes up. And similarly, if C level goes down, error goes down. If S goes down, S being the sample size, error goes down, right? They work together like that. So those ones work, it's called a direct relationship, these two. So these two are a direct relationship. They'll go together. Whereas this one here is an inverse relationship, indirect relationship. If one goes up, the other goes down. All right, there's a recap of all sorts of things that we've learned in this particular chapter. One last thing before we go, just remember that the margin of error and the width are essentially the same thing. I mean, I don't bother writing it all the time, but the error is this distance right here, from here to here and here to here. That's your error, which is half the width. So they go together. Right? If you're making your error go up, you're making your width go up. If you're making your error go down, you're making your width go down. They go together. Right? Your error is half the width of the interval. So as long as you keep that in mind, then you'll know how error and the width relate to each other. Which if you look at the formula down here, when we take that upper minus lower, that's the width, right? This down here, that's the width of the interval divided by 2. So if you want to make a note to yourself, you could say, here, I could write it right here. That's the width divided by 2. That's what you're doing, right? You're taking the width of the interval and cutting it in half, because that's what the error is, half the width.